Hello viewers, welcome back to the Multimagic channel. This video will be discussing about a simple feature as a part of product development called merging two MP4 files which has same specifications. This sounds simple, but yes, there are quite a few challenges in achieving this particular feature as a part of our Multimagic product. And on that note, let's start this video and then see what are those challenges. I would not say difficult, but little things or little challenges that we faced while uh, achieving this merge feature for same specifications. So here the limitation as of now is we will be merging two MP4 files which have same specifications. We will be discussing what is meant by same specifications. If there are two different files which has two different specifications, we are not supporting it, but yes, the work is in progress and it needs more tweaking. So that I will be sharing in the next video definitely. So but let's start with the basic thing. Yeah, so as I mentioned, see, if any container or any MP4 file will have minimum two streams. I mean, it can have either video stream or video audio along with subtitle stream. But in general, yes, we have a video stream and an audio stream. So for this particular video, I mean, I have a sample video, and for that particular sample video, these are the specifications. I got the specifications with the help of FF probe. You can also read the file and then can print everything on your own as we are doing in a product, but just for simplicity point of view, I just used FF probe. So now here is the thing. So here the codec IDs or the codec uses H264 and the format is YUV420p and resolution is 1280 into 720. Okay, and the audio the key specifications of the audio are, it is that codec ID is AAC and the sample rate is 44,100 Hertz and the channel layout is stereo and then the sample format is FLTP, which is floating point. So when it comes to audio stream and when it comes to video stream, these are the at least key specifications that we should be considering into picture when we say same specifications. Okay, so when these two specifications are matching for any of the video, let's say I take video 1, these are the specifications, and video 2 I have same specifications, then we can just simply merge those two videos using by concatenating. You don't need to read each, I mean, you don't need to encode each frame. So let's say you have a file 1, you read that file. Let's say you have a file 1, you read that file and then you get the raw data from that file and then you apply some output context or encoding specifications for it and then you transcode it. So all these things you don't need. You just need to read a frame from a file and then just write it to the output file. You don't need any encoding further process because you are just concatenating those two files. You are not kind of processing anything on it. So just read every frame, write every frame, and the second file read every frame and write it into the buffer. Okay, and for the if we have specifications varies, let's say for one video I have a format as resolution as 1280, another video has a different resolution. Obviously you can't do it like copy paste each one. There will be a lot of disturbances will be there. So in that case, definitely you need to encode. So if either of the specification is not matching, definitely you need to go. Let's say for example, codec IDs are matching, video codec ID for file 1 and file 2 are matching, but format is not matching. Yes, you need to go for encoding process while merging. And let's say if you have different sample rate for audio, yes, you have to go for merging. So if two files having same specifications, then yes, no need. But of course, so there are other specifications which does not match, like frame per seconds, bit rate. So that doesn't matter actually. Anyhow, that will be taken care default. So all that matters is the whatever specifications I mentioned here. Okay. So on that note, let's go to the next slide. Yeah, this is what I am talking about. See, when you say merge two videos, let's say I have an MP4 one file, an MP4 two file. I read this frame until the end of file and then I just write that frame using this FFmpeg API as AV write frame or AV write interleaved frames. So I'll be writing it in the output file. So all the audio frames I will be writing, all the video frames I will be writing. I just simply just write the file. I am not using any send packet or receive frame or receive packet, send packet, all those encoding, whatever APIs are used encoding inside the encoding. I am not initializing any memories. I mean the output memories, anything like that. Just I am initializing the input context here, and then yeah, I am just of course I'm merging these two files. Okay, and now after merge, I mean after setting the this is the basic idea for the merging. Okay, so now let's look at yeah, this is a bit interesting and challenging. I think it will be more clear if you look into the code that will be shown. I will show in the next couple of minutes, but the basic idea is, let's say you have two video files. This is file 1, this is file 2, and file 1, let's say you take last two frames, last button frame and last frame. Let's say the speed is 1000, the speed is 2000, and the first frame of the second video will have PTS 0, obviously, because it's starting from the start. But if you do like this during merging, this will not be good. So because the PTS is 0 and the speed is 0, so that this frame will be present during playback, this presentation timestamp is 0, then it will be go to the beginning of the video and it will overlapping with the first frame of the first video. So we need to ensure the second file starts after the end of the first file, such that PTS also needs to be adjusted accordingly. So for that you need we came up with this formula after different trial and errors and testing all this formula, and this makes sense concept wise and theoretically also. See, now you need to, of course, you need to copy. So we need to, it's nothing but you need to define the offset. So I need to, with how much offset, I need to start the timestamp for the every frame of the second video. Here I'm just discussing the first frame of the second video. So now there's nothing but PTS of the last frame. This is like 2000 plus the PTS of this first frame of second video, which is 0 at just example, and then the difference between these two, 2000 minus 4 plus 1. So it comes out to be 3001. So the new timestamp for this particular frame will be 3001. So now the sequence will be maintained. So now it will be properly merged or concatenated. Okay, so but when it comes to audio frame, we don't need the details of the last but one audio frame. We just need last frame and first frame, and then you have this timestamp is 1024 and this timestamp is 0, which is not good because it will be overlapped with the first audio frame or the audio frames of the first file. So now how to determine the correct PTS for this second frame, the first frame of the second file. So it's nothing but same, it's 1024 plus 0 plus the number of samples of the first frame or the second frame, because here the specs are same. So that's why I mentioned like specs are very important here, specification. So it turns out to be 2049 is the timestamp for this frame. So for every frame of the second file, you need to compute this. To compute, okay, what is my last frame? I mean, of course, the last frame will be constant once, but you need to accumulate this timestamp plus offset plus 1. So we need to ensure for every frame in the second file we apply this formula. This, just for the simplicity, I just explained it for the first frame, but in general you need to apply this logic for every frame of the second file. Same applies for the audio frame. So that way audio video will be in sync, and when you merge there will be no issues. So it's all about, you don't need to encode in specific, but you need to ensure that the PTS and DTS are properly set. And here also, since we are having two input files, now we need to create two input contexts. In general, you will initialize the memory and all those things only once because we are dealing with one input file. So here we need two input contexts and one output context. Okay, so let's look into the code now. So yeah, this will be a bit interesting. Yeah. So as you know, yeah, this is our code. See, I am initializing my data for all the two files. Yeah, here I am creating the context. You can see here, yes, I'm creating two. So how many number of files are there, and I'm creating the context for these two new files. Okay, I'm creating two input contexts, but output context is just the one. And I'm getting the video stream index of first file, video stream index of second file, and I'm preparing the audio decoder, everything twice I have to do for both the files. Okay, so after that you need to ensure you process the frames. As I mentioned here, there is no need of any encoding, and we start with process frames without encoding. And just a second, please. Yeah. So here you will be starting process frames without encoding, and what we do here is like, yeah. So yes, so first we set the header. Okay, this is the output format context. There will be only one output format context. We set the header for this, and then of course I'm initializing all these values, last button frame, video PTS, and all those things. Okay, and yes, I'm getting a number of samples, input context 0, get number of samples. Since it's the same spec, I can use either of the input context, whether 0 or 1, doesn't matter here. So I am iterating through my file, number of files. So I am reading the first file here. So for the first file, I'm computing, I'm storing that last video frame. I'm keep on updating the last video frame PTS because I need these values for the second file. So in the second file, what I'm doing, as I mentioned, I'm offsetting my PTS of the second file using this particular. So it's a current PTS plus the last video frame PTS plus the delta and plus 1. So I'm adjusting the PTS and DTS of the second file like this for audio frames. For video frames is all the same. So if it is first file, I'm just simply keeping the last audio frame PTS is nothing but the last frame of that particular frame packet PTS, and then now the packet last frame or the last packet is nothing but packet arrow PTS, last audio frame PTS plus number of samples plus 1. And finally I'm writing it. So here I'm concatenating two MP4 files which has same specifications. I just use two APIs here, AV read frame, AV write frame. But before writing, I ensure the second file PTS and DTS are maintained a very good offset such that the sequence is maintained well. So this is the formula for the offset. I mean how much you need to transfer the PTS and DTS of the second file for video frames, and this is also for the audio frames, how much amount of delta you need to add to the PTS and DTS of the audio frames. Yeah, so this is bit as I mentioned, this logic is bit challenging. We initially we just simply added, okay, last frame PTS plus current frame PTS will give you the new PTS of the merge thing. But no, that will not happen because in some of the files the last button frame we have one timestamp, I mean one PTS, and on the alternate frame has, and the last frame has other PTS. So you can't simply go ahead and do some addition of last frame and the first frame and then you get the new PTS. You need to ensure you compute the delta properly after checking with different understanding theoretically and checking with different input files. We came with this logic, a bit of trial and error too. And yes, so now this works good actually. And yes, but again, I'm telling again, if you want to merge three video files, we didn't test that. If there are three video files which has same specifications, yes, in that case, we didn't test, but I hope the logic might work same because we are addressing all the PTS, DTS. But yes, here we need to store the last video frame PTS of the second frame too. If you are merging three videos, so the second frame, last frame PTS also we need to. So we need to tweak this logic a bit. So as I mentioned, it's not straightforward. Our goal is to ensure we start with the simple cases, start with audio and then video, and then with simple use cases, and then go for the audio video advanced uses. Like that, we are slowly building all the blocks. So now the key thing here is you just need to maintain on how to compare the specifications here. So for that I have written, okay, this particular I have maintained this video metadata, and This is my audio metadata, whatever specifications I mentioned in the presentation. So what I am doing is I am storing the meta info of the all video information of both the files, and I am storing the audio metadata of both the files. And from my input context, I am getting the codec ID, pixel format, I am getting the width, I am getting the height. And for the audio also, I am getting all these required things: codec ID, sample rate, and channel layout and sample format. So now what I'm doing is I'm comparing, okay, if my video, if both the files have same video specifications, okay, then I say encoding is not needed. Okay, so that's what I mentioned, not of it is equal to encode. Then now I again put audio specification. So the default value of this is false. If both the specifications are not matching, then I said encoding is needed, else I leave it like this. Same here, if at all, if this is encoding is false, it means encoding is not needed for video. Then it will come and check for audio also. Audio also will compare the metadata here, and then it says if the specifications are same, then encoded needed, it still remains the false. So like this, you compare the specifications and you come to a conclusion. Okay, now I have two files, whether specifications are matching or not matching. Based upon that, I am telling, okay, if encoding all input context or no encoding is needed, and I can select input selected is 0, it here is means like, okay, the context I am selecting, okay, I am picking any of the file for the output specifications. I like, and now yeah, so if specifications are different, yes, we need to compare different things. That logic is still in progress. Here I'm comparing the width and height, and then a lot of, so based upon the width and the height, you need to ensure which file specifications should be used to the output context. Let's say you have two files, file 1 and file 2. Let's say I'm going with file 1 specifications. File 1 specifications, then the output context of the final output file should take the specific reference as the first file. You can't take a second file. So that's why maintaining this particular variable called in which input file you are taking as a reference. The selected context is of file. Because why this particular data is needed is, here you need to process frames without encoding, and then here you need to get the different context. Okay, if I need a reference of which video file, which stream index, so you can take any of the file. So, but if you want to specifically mention only this file, then the encodings are not matching. Okay, so like this, we created input context twice and then output context once, and ensure how our output context is initialized properly. And then in case of encodings are not matching, the speakers are not matching, we just left a hook. But as of now, if this is file, we are not doing anything in the process frames. As I mentioned here, we're just, if encoding is true, means this if condition will not hit, it will try, and I'm not doing anything, and I need to add my code here. Okay, so that's how you merge two videos. Let's run a demo of this merging two MP4 files which has same specifications. So here are the arguments I'm passing to our application. So the input, so the function type is 8, which means like merge, and a hyphen I1 is the input file 1, and I2 is the input file 2. Since we are doing merging of same spec, for simplicity I am passing the same file again. Yes, you can also choose a different file which has a different spec, same spec with a different video. But yeah, just for simplicity point, if I just choose same video, and now let's run our application. Okay, so it says merging is done. Okay, it's too fast because we are just reading, writing, we are not doing any encoding or transcoding. So here you can see, yes, the video decoder is this, and this is the first context. This is the audio video stream of the first video. Yes, this is the audio video stream of the second video. Of course, both are same. And now it is merged. So let's see how the merged video looks like. So it is in my download folders. Yeah. So you can see now the total length of the video is 5 minutes 2 seconds. So let's see how it is. The sync is good, and then I'm just forwarding. Okay. Okay, it's almost end of first video. Yeah, so let's see whether it is coming good. Yes, you see.
No one's allowed to talk. Is that it? Can't talk?
No, you intimidate them.
Good God, you're a woman. Is it better to be feared or respected? I say, is it too much to ask for both?
So, so as you can see, the merge is perfect here. Okay, which has same specifications. Okay. Hope everyone enjoyed this particular video, and yes, we will be adding more videos in the coming sessions, like how to merge two videos which has different specifications, and also during playback how to control slowness along with video and audio, and for more generic like 1.5 factors, all those interesting details will be coming, and this merge also how to merge more than 2 files, 3 files. So all those things will be coming up in the upcoming sessions. So yeah, until then, keep watching our space. Have a good day. Bye bye. Take care.